All right, our objective for today is solving equations in either the 0 to 360 interval or the 0 to 2 pi interval, and instead of working off the unit circle, we are going to use our graphing calculator to obtain decimal approximations. Before we dive into these examples, I'll do a quick pre-example so we have a point of comparison of what we know to what we don't know. All right, one of the things we looked at a few lessons ago was if we wanted to solve the equation, the sine of theta is equal to 1/2. Back when we were doing SOHCAHTOA trig, there was only one answer to that particular question because there was only one angle that you could take the sine of that made sense in the context of a right triangle and obtain 1/2. And then what we did is we expanded the way we thought about angles. Instead of a piece of a triangle from a geometry book, we're looking at it as a rotation in a coordinate plane. So there are an infinite number of angles you can take the sine of and get 1/2. Very often, once you leave that right triangle trig world, the common interval that they want to know is the 0 to 2 pi. So the way that we did this was we looked at the unit circle. Where on the unit circle was the y coordinate 1/2? It happened at two locations, at pi over 6 and at 5 pi over 6. Now if we happen to have been in degree mode, 30 degrees, 150 degrees would be the two solutions. Well, what happens if that number does not appear on a unit circle? Well, there are some times that we're going to be able to figure that out when we learn more trig a little bit later in the course, but for now, if that number that's on the right-hand side is not something we can obtain directly from a unit circle, then we need to use technology in order to answer that question. And that's what brings us to the new stuff for today, which is to complete this worksheet. All right, I already have the answers worked out here. Focus this in. Okay, so our instructions for the first group here are to solve each equation 0 to 360, and we have specific rounding instructions of rounding to the nearest tenth of a degree. So comparing this to the example I just did, 0.732 does not appear as an x-coordinate on a unit circle. So the unit circle is not an option in order to solve this equation. So if that's the case, we're going to go to a calculator. Clear this out. Make sure I'm in degree mode. I am. I'm going to type in the inverse cosine, 0.732, and I get 42.9 degrees. Now, sometimes the number that you get on the calculator isn't in the interval that you want. For this first example, it is. 42.9 degrees is in the 0 to 360 interval. So that's one of the two solutions we're looking for. Now, we remember from the unit circle problems we did that for these, unless it's a quadrantal angle or a no solution, we expect two answers. So, where else in the 0 to 360 interval can we take the cosine of an angle and get that decimal right there? Well, what we're going to do is remember that all seniors talk constantly. That 42.9 degrees, that's a first quadrant solution. We know that we also need a fourth quadrant solution. So what we're going to do is we're going to find that reference angle. In the first quadrant, you are your own reference angle. It's 42.9 degrees. And then we need the solution coming around in this direction that has the same 42.9 degree reference angle. So what we're going to do is 360 minus that 42.9 and get our second solution of 317.1. Usually these aren't too bad to check on your calculator. So if I type in the cosine of 42.9 degrees, I should get something close to the 0.732. Now it's probably not going to be exactly that number because of the fact that 42.9 is an estimation, but we should get something close enough to do a good check. So I'm going to check cosine of 317.1. And again, I get a number very close to what we should get to check the answer. Okay, second example. The tangent of what angle is negative 10.430? We can't get this on a unit circle because there is no place on a unit circle. If we divide the y-coordinate by the x-coordinate, we're going to get that decimal. So we're forced into using technology. So that's the first thing I'm going to type in my calculator, the inverse tangent of that decimal. The calculator says negative 84.52. Negative 84.52 is not in a 0 to 360 interval. Therefore, it's not one of our solutions. What they did was they gave us the fourth quadrant solution, or it gave us the fourth quadrant solution, rotating in a negative direction. So what we have to do is get the fourth quadrant solution rotating in a positive direction. So we're going to go 360 minus 84.5. That gives us that solution right there. We know from all seniors talk constantly that tangent is negative in the second and the fourth quadrants. So now what we need is that second quadrant solution right there. They both have to have the same reference angle. So we're going to go 180 minus the 84.5, and that gives us the 95.5. So those are our two solutions in 0 to 360. Okay, next example. Cosecant of what angle is negative 0.3753? We've done this many times. We can't deal with this as a cosecant equation because we don't have an inverse cosecant button on our calculator. So we're going to convert it over to a sine equation. Then we're going to use the inverse sine. We're going to type this in our calculator. The inverse sine of 1 divided by negative 3.753. And we're going to get negative 15 point something. Okay, negative 15 point something isn't in a 0 to 360 interval. What they did, or what it did, was it gave us the fourth quadrant solution rotating in a negative direction. We need to get the fourth quadrant solution rotating in a positive direction. So it'll be 360 minus 15.5. That gives us that solution right there. We know sine and cosecant are negative in the third and the fourth quadrants. They both have to have the same reference angle. So if we're 15.5 degrees away from there, we have to be 15.5 degrees away from there. So 180 plus 15.5, 195.5. All right, last example in degrees. We have a secant equation. We're going to need to convert that over into a cosine equation. Oops, didn't have this under 1. Then we're going to take the inverse cosine of that decimal. It gives us a solution of 130.7. Well, we know cosine and secant are negative in the second and third quadrants. So that 130.7 is the second quadrant solution. What we need is the third quadrant solution. So we're going to find this reference angle in here. 180 minus the 130.7 is how far away it is from that closest x-axis. So that's like a little less than 50 degrees. Then we're going to go that far past 180 plus that number, and that gives us our two solutions. All right, so that's our run through of your typical types of examples when you're solving for, zoom back out a little bit here, the 0 to 360 interval using technology. All right, now a question many students have is, why is the calculator giving us those numbers that are not 0 to 360? Doesn't the calculator read our mind? Doesn't it know what we want? Well, the calculator is pretty advanced, but it's not necessarily designed to answer this question of the 0 to 360. For reasons we'll talk about when we learn more trig, there are particular reasons why the calculator gives you certain numbers that you get. Based on what we know at this point in the class, it's pointless to talk about it. We don't know enough trig to intelligently address that particular issue. In a little while, we will. Right now, what this comes down to is you get what you get from the calculator. If it's not exactly what you want, you know enough math in order to figure out what you want, which is why we spent that time talking about reference angles. All right, now what's going to happen here is we're going to do the same types of questions on the bottom, except now we're going to answer them in radians. Now, unless it's a nice, clean, exact unit circle type of radian, like pi over 4, it tends to be in pure decimal form. So our answers are kind of going to have this flavor right here. Now, when we were working with reference angles and finding additional solutions up here, we were either adding and subtracting off of 180 or adding or subtracting off of 360. Well, now, if we're in radians, instead of adding or subtracting off of 180 or 360, we're going to be adding or subtracting off of pi or 2 pi, because 180 degrees is pi radians, 360 degrees is 2 pi radians. Okay, another issue is you usually need more accuracy. And what I mean by that is 1 decimal place is usually pretty good. Sometimes you need 2 when you're working with degrees. 1/10 of a degree is very small. Now, in contrast, a radian, just to kind of give you a little bit of perspective, that's pi radians. Well, pi is about 3.14. So for the purposes of just a quick visualization, let's just round it to 3. So from there to there is roughly about 3 radians. So that means that 1 radian is in a neighborhood of 60 degrees. So rounding to the nearest 10th, a lot of times that's not accurate enough. We get unacceptable rounding errors, especially if they become intermediate steps in larger problems. So it's typical to expect that they're going to ask you to round to more than 1 decimal place when you're dealing with radians. Specifically here, we're going to go to the thousandths, which is 3 decimal places. So, mode awareness. Mode, we need to be in radian mode for these on the bottom. This first problem, we're going to do the inverse sine of 0.421, and we get about 0.43. Now we know sine is positive in the first and the third quadrant. I'm sorry, first and the second quadrant. So which is that? So what I'm going to do is make a little notation. Well, what would halfway be? We know this is about 3.14. So halfway between 0 and 3.14, pi over 2, we're looking at about 1.57. So that 0.43 radians, that's referring to the first quadrant solution. So that's one of our 2 solutions. Now, if we were in degrees, whatever that degree number is, we'd be subtracting from 180. Now it's whatever the radian number is, subtracting from pi. So pi minus that 0.435 gives us the other radian answer. Now the same as above. I didn't check all of those, I just checked the first one. We will verify that that seems to be reasonable. So I'm going to take the sine of 0.435, and I should get a decimal close to 0.421. I'm going to take the sine of 2.707. I should get a decimal close to 0.421. I do. Now, these guys are estimations. They're not exact. So it's unlikely for us to get exactly that number, but we should come close. Let's zoom in a little bit here. All right, next example. We are going to do the inverse cosine of negative 0.355. The calculator tells us 1.934. Just do a quick check with that. Inverse cosine, negative 0.355. Yes. Now, when it comes to locating angles and degrees up top, you guys have enough experience in thinking in terms of degrees to quickly locate where it is. I'm going to use the same strategy I did here in terms of, well, where is 1.934 radians? Where is that located? Well, we know it has to be in the second or third quadrant because that's where cosine is negative. So we'll make the quick. That's 1.57. That's 3.14 approximately. So the 1.934 is right in there. So we need to get that reference angle, pi minus that 1.9 number, and then once we have that, do pi plus, go that far past. So this gets the reference angle, add it, and then it gives us the other solution of about 4.349. Just to verify that it lands in this quadrant, remember this in radians all the way to there is 3 pi over 2. So 3 pi divided by 2, we're looking at about 4.71 radians. So that 4.349 falls between 3.14 and 4.71. So it doesn't guarantee it's exactly correct, but it's certainly reasonable. All right. So this one here, we're starting with a cotangent equation. We need to convert it to a tangent equation. Then we're going to do the inverse tangent of both sides. The calculator gives us that answer back again. So what that is that is the fourth quadrant solution rotating in the negative direction. So what we need to do is get that same solution rotating in the positive direction, or the coterminal solution rotating in the positive direction. So that'll be 2 pi minus the 0.195. 2 pi minus 0.195, that gives us that 6.08 number. Now we need the second quadrant solution, so that's going to be pi minus 0.195. That gives you the 2.946. Last problem from this worksheet. We need to convert our secant equation over to a cosine equation. Then we need to take the inverse cosine of that number. Calculator tells us 0.722. Well, we know cosine and secant are positive in the first and the fourth quadrant. That's the first quadrant solution. To get the fourth quadrant solution coming this way, it's going to be 2 pi minus 0.722, and that gives us approximately the 5.561. And those are our two 0 to 2 pi solutions in radians in decimal form.